Hello everyone and welcome to this exciting Arduino UNO PWM project in Tinkercad. That is a pulse width modulation. Today we will learn how to control an LED brightness, DC motor speed, buzzer sound and servo motor position using PWM signals. You will see how Arduino creates analog-like output using digital pins in a simple and practical way. These components are widely used in robotics, automation, alarm systems, and smart electronic projects. So let's start building and understanding the power of PWM with Arduino UNO step by step. So first we'll know what is pulse width modulation. Pulse width modulation, it is a technique which is used to control the amount of power supplied to an electronic device by turning on the signal, okay, and off very quickly. Now how it works? Instead of giving a continuous analog voltage, here Arduino produces a digital pulse signal with varying on time. Okay, that is, here we will be varying the on time and the off time. That is, will vary only the on time, automatically the off time gets varied. High is nothing but a 5 volt voltage and low is 0 volt. Now here you have something called as a duty cycle. So duty cycle D is the on period, okay, that is the T on divided by the period. Period is nothing but this complete cycle, okay, for which the signal is on and off, into 100%, that will give you the duty cycle. So duty cycle, if it is 0%, then the signal will be off, okay, that is here you will have a complete off signal. And also here you will have a off LED, okay, if it is off. Now next second is the duty cycle 50%, it will be half on and half off. Then duty cycle 100%, it will be fully on, there will be no off period, it will be fully on. Now by changing the duty cycle, okay, that is by changing this duty cycle, we can control the LED brightness. That is, first the LED will be off for 0% duty cycle. Then if we increase it to 25%, it will be slightly brighter, then brighter and brightest here. Okay, bright, brighter, brightest. Here it will be somewhat dim, then it will increase its brightness. Then again it will become fully bright for the 100%. Also you can control the motor speed here. Then you can control the servo movement. And also you can control the sound generation. That is, the sound will be first slow, then it will become a bit louder and then loudest. Here example for LED brightness is been shown here. So if it is 10% duty cycle, then your signal is on for a very short duration here. So the LED is having it is dim, okay. Then here if you increase the duty cycle to 50%, that is for 50% of the period it is on and for 50% of the period it is off, then it will be slightly brighter. If it is 90%, that if T on is longer, then it will have some more brightness than the previous one. So PWM is simple, efficient and widely used in Arduino projects for the real world control. Now what is duty cycle? Duty cycle is a percentage of the time a digital signal remains on, okay, that is high state during one complete cycle. This is one complete cycle, okay. So duty cycle formula is what? On time divided by the total period into 100. So on time is duration when the signal is high, okay, and off time is duration when the signal is low, and period is total time of one complete cycle, that is on time plus the off time. Now how duty cycle affects the output? Here the period remains constant, okay, this period remains constant while only the on time changes. Here this is the correct period, okay, that is the T on plus T off time is the period. Here you can see this period will remain constant, and increasing the on time, that is, if we increase the on time, then here it will increase the duty cycle. That is, it will increase the average output voltage and power supplied to the device. Okay, as you increase the on time, then the average output voltage which is supplied and also the power which is supplied to the device will be increased. So if you have more on time, then there will be a higher duty cycle and there will be a higher average voltage. Therefore, the device will get more power. So the working principle of the PWM duty cycle is like this here. So PWM is a digital signal that switches between high, that is the 5 volt, and low, that is the 0 volt. Now if you consider this as the period, that is T on plus T off, here this is 25% duty cycle, that is for the 25% of the period the signal remains high, then remaining it will be low. Similarly here 50%, it will be on for 50% of the period and off for the 50% of the period. So changing the on time while keeping the period constant changes the duty cycle. Okay, the period is constant here. You can see in all the three the period is constant. Just we are changing the on time of the signal, which will change the duty cycle here. So T, that is period, is the total time of one complete on and off cycle. If it is 0%, that is the duty cycle is 0%, the device will be off. If it is 100%, it will be fully on. If it is 25%, low brightness or low speed. If it is 50%, medium brightness and medium speed. If it is 75%, high brightness and high speed. So these are some of the application of the PWM, that is LED brightness control, DC motor speed, servo motor position, and the sound buzzer generation. So here you have this for 25% duty cycle, where it is on for 25% of the period, where the output effect is like this. The LED will glow dimly, the DC motor will rotate slowly, and very little power is delivered to the load. And also this is suitable for low power operation. Fine. So here what happens, it is on for 25% of the period, and for remaining 75% it is low. Here this is the average output calculation. How you will calculate the average output voltage? That is the 5 volt. Okay, high voltage 5 volt into 25% duty cycle is equal to, you will get 1.25 voltage approximately. So this will be the voltage, average voltage, okay, for 25% duty cycle. Similarly, this is for the 50% duty cycle, 5 volt into 50%, it is 2.5 volt. That is total voltage is 5 volt. Its half, it will be 2.5. Here the effect of this is LED produces medium brightness. In previous 25% it was dim brightness. Here it is medium brightness. And here the motor rotates at medium speed and moderate power is supplied. This is for 75% of the duty cycle. So again here the average output voltage is calculated like this, 5 voltage into 5 volt into 75%, that is equal to 3.75 volt. This will be your average voltage. Now here the LED will be brighter than the previous one of the that is of the 50% duty cycle, and the motor will rotate faster, and here you will be having a higher average power which is delivered. So here the signal remains on for 75% of the time period and it remains off for the 25% of the time period. So here this is the effect, summarized effect of the duty cycle and the output effect. You can see here this is for 0%, it remains off, LED is off, motor has been stopped, and here average output voltage, it is 0 volt. Similarly, as you increase this, these all will increase, and for 100% you have the PWM waveform for whole complete time period, and the device will be fully on. The LED brightness will be fully bright, the motor will rotate with maximum speed, and average output voltage will be 5 volt. This is the period. Here you can see this is the total period is 8 millisecond. Now the signal is on for 2 millisecond and it is off for 6 millisecond. Therefore total time, okay, that is the period is on time plus the off time. On time is 2 millisecond, off time is 6 millisecond. So here the period, it is the total time for one complete cycle, and it is the inverse of the frequency. T is equal to 1 by F. Now in PWM, the period usually remains constant while the on time and the off time it will be changing. On time is here, as you change the on time, the duty cycle will be changed. Okay, so this is 25% duty cycle. Total period is 8 millisecond. When it is on for 2 millisecond, it will be 25% duty cycle. If it is on for 4 millisecond, it will be 50% duty cycle. If it is on for 6 millisecond, it will be 75% duty cycle. These are some of the applications. That is, again, it is the same thing. That is, if it is 0% LED will be off, 25% it will be dim, 50% it will be medium, and 75% bright, 100% it will be maximum brightness. That is, it will reach maximum brightness. So this is for the DC motor speed control. Now here the voltage calculation is also being shown for 0%, 25%, then 50%, 75% and 100%. Here for 0% the motor has been stopped. For 100% it will rotate with maximum speed. For 25, 50 and 75% it will rotate with slow, medium and fast respectively. And the voltages for 0% up to 100% are given like this. Okay, you know the calculation which I have shown in the previous slide. So here the Arduino will send the PWM pulses to the motor. The driver switches the power on and off to the motor. Okay, so at low duty cycle what happens? The motor gets less average voltage and it will rotate how slowly. Now at high duty cycle what happens? The motor gets more average voltage and it will rotate faster. And at 100% duty cycle, the motor gets full voltage continuously and it will rotate with maximum speed. So here PWM, it is an efficient way to control DC motor speed, and also it saves power and reduces the heat. And it is widely used in robotics, drones, RC cars, conveyors, fans, etc. And similarly here you have the servo motor position control. This is one application, and sound and buzzer generation. In servo motor, you can change the position of the servo motor from 0 degrees then to 90 degrees to 180 degrees by changing the duty cycle. Okay, so here if it is 0%, okay, here if it is 0, that is the position of the servo motor is left. Now for center, here it is 90 degrees, and for 180 for the right side it will be 180 degrees. Okay, and this is the angle. And similarly for sound and buzzer generation, so by changing the pulse characteristics, again you can here the Arduino can produce different frequencies and tones to drive the buzzer and the speakers. So Arduino, what it will do, here it will generate the PWM signal, and which is given to the driver circuit. Here the buzzer or the speaker, it will produce the sound. So if it is a low tone, then the PWM frequency will be 500 Hertz, and if it is a medium tone, it will be 1 kilohertz. For high tone, it will be 2 kilohertz. So as the frequency is increasing, the sound is also increasing. So here, changing the PWM frequency, it will change the pitch, that is the tone of the sound, and changing the duty cycle changes the loudness, that is the volume. Okay, and PWM is an easy and efficient way to generate sound using the Arduino. These are the components required for the PWM experiment using the Arduino UNO. And here we will be using a Arduino UNO, then LED, 220 ohm resistor. You can use 1K resistor also, one buzzer, DC motor, servo motor, then a breadboard, jumper wires as needed. You need a USB cable. You need an oscilloscope, a multimeter to know the voltage. Okay. Now here, one more thing. Whenever you are using PWM in Arduino UNO, you can see some pins at the digital pins. It is labeled here like you have a tilted sign here. These are the tilted sign. Whenever you are going for a PWM experiment or project, you have to use these pins. Okay, that is pin number 3, 5, 6, 9, 10 and 11. These are the PWM pins. Okay, so Arduino provides PWM on 6 digital pins, and these pins are marked with the tilt. and you can use analog write pin comma value on these pins. Okay, whenever you are using this, you can write analog write pin comma value here. And PWM, it is idle for controlling the LED brightness, motor speed, servo position, and buzzer volume, as you have seen in the previous slides. Now, for example, suppose I am writing here analog 9 comma 128. 9 is because I am using pin number 9 here, so I have written 9. Now 128. So here you can write the value from 0 to 255. Okay, 0 is for off and 255 is for on. It means if you write here 0, you will get a 0% duty cycle here. So this the whatever device you will be using, it will be always off. If you write here 128 or 127, you will be having some 50% duty cycle. Okay, it will be half on and half off. And if you write here 255, it will be fully on. So this value, it should be varied from 255 to 0 to 255, that is in between 0 to 255. Now here I'll show you two programs. First is the LED or any device which you are using, it will change. Suppose I'm using an LED, it will change its brightness from 0 to 255, that is from off to very high. Okay, so here the brightness will increase, then again the brightness will decrease for this program. Okay, here we are defining the LED pin, that is equal to 9. We are using pin number 9 here, digital pin number 9, that is the PWM, and which is used for PWM. And then this is the white setup, which will be running for one time. Now here this loop, it will be running infinitely. So here for this one, here first I'll tell you this, that is analog write LED pin. Okay, it will send a PWM signal to the pin 9. Okay, here we are using analog write LED pin comma I. So here it will send the PWM signal to the pin number 9. So LED pin, we have defined this variable as 9. Now 0 LED is off, for 255 LED is on. Here you have two loops. So the first loop, this will increase the brightness from 0 to 255, this first loop 0 to 255, and in the second loop here the brightness will decrease from here the brightness will decrease because it is changing the value from 255 to 0. Okay, this is the first program, that is for the first loop the brightness will be from 0 off to maximum. Then in the second loop it will be from maximum to 0. This is the program which we'll be seeing, and this is the connection. When we connect a LED, we can see the output on an oscilloscope, and also we can see the voltage. Okay, average output voltage. This is the average output voltage. And this is another example of Arduino PWM example. Okay, here what I'll do is I'll directly change the value of the here duty cycle. Okay, if it is as you know that it is, the value should change from 0 to 255. If it is 127 or 128, then it is 50% duty cycle. So here I've written 127. So what you get is, you get a 50% duty cycle. Now we have defined here pin mode LED comma output. This will run once and sets the pin number 9 as the output. That's the first loop. This white setup loop, it will run only once, and here this will run repeatedly. And here we have declared the LED variable, and we have assigned it as pin number 9. Okay, so int LED 9, this will store the LED pin number, and then you have pin mode LED output. This will set the pin number 9 as an output, and analog write LED 127. Here it will output PWM with 127, that is the 50% duty cycle. So the result will be what? The LED will glow at 50% brightness with average voltage of 2.49 volt. Okay, and this is the voltage calculation here. This we have seen in the previous slides, how to calculate the voltage. So in previous one we were taking the T on time. but here as we have the PWM value, okay, this value we have, so we'll substitute this value here. PWM value divided by 255 into 5 volt. Whenever we have PWM value, we have to use this formula. Whenever we have the T on and T off, T on and period value, then we have to use the previous formula which we have seen. Okay. So this is the code. This is when we connect a buzzer along with the LED. Then here we are connecting a DC motor. This is a DC motor, and this is the servo motor. Okay. Here now we will see the connections and we'll execute the programs here. You go to Google, type Tinkercad, click on this first website, go to create circuits, now what we need, first we need an Arduino, so click on that and drag it here. I will zoom in this. Next we want a breadboard, so here I will attach, I'll take the breadboard, I'll drag it here. This is the breadboard. Now we need one LED. Okay, we need one resistor. For timing now we need this. Now I'll connect the LED here. Okay, then I'll take the resistor. You can take 1 ohm resistor, 1 kilo ohm resistor, or you can take even 220 ohm resistor. I'm taking 1 kilo ohm resistor here. Now connect to the negative leg of the LED, that is the cathode. Okay, after connecting this, connect one end of the resistor to the ground, here ground. Okay, ground. Next here, this must be connected to pin number 9, as we have taken the digital pin number 9 as the PWM. So we'll take this and I'll connect here. Okay, this is pin number 9. I'll change the color of this. This is black because it is connected to ground, and this is the output signal. So here I'll take it as red. Okay, now we have to show the output of the PWM signal. So what we'll do is click on this. Now click on all, search for oscilloscope, OSC. So you are getting an oscilloscope here. Click on this and drag it here. Okay, this is the oscilloscope. Now here you have a black wire, black pin here. This must be connected to the ground. Okay, so first I'll connect here. So this is the ground. I will change the color of this to the black. Now this must be connected to the anode of the LED. So from here we will take I will correct this. Let it be. Okay, it is connected here. Now this must be connected to the ground. So from here connect to this. Delete this. Okay, So this wire I'll make it as red. Fine, we have connected this all. Now we'll go to, sorry, first we have to write the code. Stop this simulation, go to code, select text, continue. Now I'll take the program from here. First I'll take this program, okay. You can type or you can paste the program. Now start simulation. See, here you can see even the LED has been, it is glowing here, okay. I'll stop and I'll show you once again. Now it has stopped. See the color of the LED, okay. Now I'll start simulation. So the color of the LED has been changed and you are getting the output in the oscilloscope. That is, you are getting the duty cycle here. I will change the duty cycle. I will make it smaller. I will make it as 64. 64 is for 25%, I think. So start. See. Now again here, the on and off period, it has been changed and the LED is glowing with somewhat dim, okay, dim light. Okay, now I will change it to 200. Again, here the on and off pulse, it is changed and the LED is glowing with somewhat brighter color. Okay, so this is about the LED. Now what we'll do, here I'll connect one buzzer. Okay, first I'll take a DC motor, or you can take a buzzer also. I'll search for buzzer. So this is buzzer here, drag it. Now this must be connected to the pin number 9, that is the LED. Okay, anode of the LED here. Okay, and here I have not changed the color of this line. I'll change it to red. And this is ground. So here this is ground. We'll see whether we'll get sound or no. Stop it. I will here I will take the first program, that is a longer one. So here what happens, if you take this now, the sound will increase, then it will decrease. So here, now again go to code. I will change this code here. Control V. Start. The color of the LED, it is varying automatically. Here you can see the color of the LED. See the color of the LED. this is about connecting the buzzer. Now we'll remove this buzzer and we'll connect a DC motor here. Motor. This is the DC motor. Okay. Again, same thing. This is terminal 1 and this is terminal 2. You connect one terminal to the anode of the LED and one terminal to the ground of the ground. Okay, like this. Now start simulation. See, the motor is running. Here you can see the motor is running. Okay. One more thing I forgot to tell here. You can see the voltage also. So for that we'll take the multimeter. We'll connect a multimeter. Okay. Type multimeter here, we'll get multimeter. Take the multimeter here. This is the positive end. So positive must be connected to the anode of the LED. And this must be connected to the, and ground must be connected to the ground. Okay, here. Now this is black. Okay, and even this is black. Fine. Now we'll start simulation. See, here you can see the voltage. Okay. Now here like you can see, we are getting one message here. Okay, red color. That is a warning that you should connect a resistor. Okay. Oh, just a minute. Wait, I'll remove this. I'll remove this. Here this point must be connected to the anode. Okay, and this point must be connected to the ground. So here this is red. Now start simulation. So it is rotating. Again it is showing that message. It means that we have to connect this here. Okay, that is to the ground. We must have a resistor here. I will take one resistor from this. Okay, you take 1 kilo ohm resistor like this, and what we'll do is we'll connect it to resistor, and then I will connect it to ground. Now we'll see whether we'll get the same message or no. So start simulation. Now we are not getting any message, warning message. Okay, so here you need to connect a resistor. Otherwise what happens, the Arduino will get damaged here if you don't connect a resistor. See, here it is rotating with the value is changing now. It is increasing, then it is decreasing because of the two loops which are being used in the code here. Here this first loop, it will increase the speed, then the second loop, it will decrease the speed, and here you are getting the voltage. One more thing is we'll connect a servo motor. So we'll search for a servo motor. Servo. So this is a servo motor. I'll remove this now. Okay, DC motor, I'll remove it. Here this also I will take it out. Now here it is having 3 pins. So first must be connected to ground, to the ground. Then here this pin is power pin. So this must be, just a minute, middle one is a power pin. Okay, this must be connected to the 5 volt of the Arduino. Okay, so what I will do is, first I will take 5 volt from here. Just a minute. Now I'll give connection to the breadboard here, 5 volt. Now I'll connect from this point, power point, to the 5 volt, and here this is a signal must be connected to the anode. Now start simulation. See, the motor is rotating. Okay, here it is going to the 0 position, then it is varying its position to 180 degree, again it is going back to 0 position, 0 angle, 90 degree, then 180 degree, like this. Okay, and also the voltage is varying here, and here the duty cycle is also varying from 0 to the maximum. So this is about connecting and varying and controlling the like speed, brightness, and also the frequency and the volume of the buzzer. Thank you.